Okay, this is 4.4a, and we're going to talk about two more ways to prove triangles. We already know the side, side, side method, where all three sides are the same length. Here's another two methods. We have side, angle, side. This angle has to be the included angle between the two sides. Something like this. If these two sides are the same as these two sides, and this angle between the two sides are the same, then there's no way to not have the third side the same. The other way to prove triangles in this section is HL, and this is only for right triangles. It's called hypotenuse leg. We know that all right triangles have a right angle. So if the hypotenuses are the same size and the leg, either one of the legs, are the same size, then we can say that the triangles are congruent. Alright, so let's look at number 1 up there. Use the diagram to name the included angle between the given pair. So AB and BC. What angle is between AB and BC? Well, they both have a B in them. They end with B and they start with B. So B is the angle. We can't just say B because there's two different angles coming off of B. So we need to say that it's angle A, B, C. And that includes A to B and B to C as the two sides. Let's do one more. 2. B to C and C to D. Well, this time there's only one angle coming off of that. So if I wanted to use a shortcut method, I could just say angle C. But another, probably more proper way to say it would be angle B, C, D. Okay? Now, let's look at number 7. Decide whether enough information is given to prove that the triangles are congruent using the SAS congruence postulate. Alright, number 7. It tells us that angle ILM equals angle T, congruent, and that's given. It tells us that a ILM A segment is congruent to TA segment. And remember, I went from outside to inside to inside, went to the same direction every time. Okay, so I have one side and one angle. Do I have another side? Well, yeah, they share AE. So we also know that AE is congruent to itself, AE, from the reflexive property. Now, I have two sides and an angle, but is this two sides with the included angle? No, because M and T are outside of those two sides. So this would be no. I do not have side, angle, side. Because for side, angle, side, I would have to say that angles, those two little angles on A would be equal. So, one more really quickly. Let's look at 8. I have the side from A to K, a side from T to K, a side from D to K, a side from S to K, and I have those little K angles. So 8 is yes, I do have side, angle, side.